So, does this tell us what the class equation for A5 is? If we just took the total number of each of these things for the even permutations, what we'd get is 1 for that one, plus 15, plus 20, plus 24, which does indeed, let's see, 44, 54, 59, 60, which does indeed equal 60. Now this is true, this is a true fact. 1 plus 15 plus 24 plus 20 does equal 60, but this cannot be the class equation for A5. This cannot be the class equation for A5. Why not? Because look, these numbers don't all divide 60. If this was a conjugacy class in A5, it would have to divide 60, and this one doesn't, because 24 does not divide 60. So 24 cannot be a size of conjugacy class in A5. So the moral of that story is that just because elements are conjugate in S5, it doesn't mean that they're conjugate in A5. And the reason is that they might be conjugate in S5 via an odd permutation, in which case it's not, that odd permutation is not an element of A5, so that doesn't necessarily mean that you're conjugate inside A5. So let's just write that down. Just because A and B are conjugate in S5, S5 does not mean they are conjugate in A5, because maybe B equals GA, G minus 1, where G is odd, where G is an odd permutation. So that's not conjugate in A5, but only in S5. So conjugacy in A5 is much harder to work out, and we'll see how to do that later. Conjugacy in A5 is much harder, and we'll do it later for the sake of putting it off until later. Right, so at this point let's stop and write down what some features are of the class equation that help us work out what possible class equations are. Because we had a look at the numbers in the last case. We just looked at the numbers involved in a potential class equation for A5 and already discovered that that couldn't possibly be the class equation. So features of the class equation. So first of all, the number 1 has to appear in a class equation, because the identity is always in a conjugacy class all by itself. 1 must appear as E is always a conjugacy class. Because if you think about it, how could anything else possibly be conjugate to the identity? Because if you did G, E, G minus 1, all you could ever get is the identity. Okay. Every number has to divide the order of G. every number must divide the order of G, because each one is the size of a conjugacy class, and finally the numbers all have to add up to G. Everything must add up to G. So let's do another example where we just use these facts. Example 6.2.4, I think, 6.2.4, yes. So let's do an example where all we know about this group is that its order is 7. Now, if 1 has to appear, right, then we've got no choice, because there aren't any other numbers less than 7 that divide 7. So all we can have is a whole load of 7s. We must have 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. That's the only thing we can possibly have. And of course, we know that this is true, right? Because we've already seen that if G is 7, then G has to be the cyclic group of order 7, because 7 is prime. And if it's a cyclic group of order 7, this is abelian. This has to be true anyway, because G has to be isomorphic to C7, so it is abelian. And if you're abelian, remember, then nobody is conjugate to you except yourself, because G minus 1 is always going to equal A if you're abelian. So you can conjugate and conjugate until you're blue in the face and you will never get anywhere. So each of these things, every element is in a conjugacy class all by itself. So every element is in a conjugacy class all by itself. And of course this is true for any prime number. True for G having order P, any prime number. So that tells us about the class equation for cyclic groups. Let's try another example now. We're going to suppose that G has order 8. Example 6.2.5. This is where G has order 8. Okay, so what possibilities are there for this? You should now stop and see if you can work it out. Oh, we did it on the last tutorial sheet. Well, maybe you haven't done it yet. If you haven't done it yet, stop now and see if you can work out what all the possible class equations are for a group with 8 elements.